Hi, it's Mr. Mabry. In this session, we're going to talk about how energy is transferred from the sun into our planet using the three-step process of radiation, conduction, and convection. You're going to probably want a stylus for this one, guys, or a really agile finger to get all the drawing down. So here we go. First, I'm going to start off with a handy-dandy yellow for my sun. And in my top left corner, I'm going to draw the sun beating down from its celestial place in our solar system, sending out its life-giving warmth to all of its planets, especially Earth. And I'm going to draw a nice, especially big, long ray. Here we go, down to the planet. Beautiful. And let's go ahead and draw a nice atmosphere it's got to go through. And did you know that when the sun's rays hit our atmosphere, that not all of it goes through? Some of it hits it and bounces off. And then some of it hits it and is just sort of absorbed and sucked up by the molecules of our atmosphere. And then some are able to penetrate it and go through. We think approximately 30% of all sunlight that hits our atmosphere is reflected. And we think that, 20% or so is absorbed. And so give or take 50% is what is available to reach the surface of our planet. Okay? So let's talk about that 50% that does get through. Of that 50%, a good amount of it's going to hit the ocean. And then next to the ocean, we better draw the shore and maybe a little happy tree there next to the shore. And so, yeah, the sun's rays are going to hit that. And when it does, why don't we go ahead and start writing those processes we were talking about? So I'm going to take my red marker and sort of indicate here is the ocean getting warmed up directly by the sun, and here's the ground and the happy tree. And so this red is meant to symbolize the first step of the process, so step one, and that first step being radiation, which, as you know, is energy transfer from the electromagnetic spectrum, directly energy received from something given away that source, which in this case is the sun. So everything warms up, boom, heat waves hit it from the sun. Now the second and less intuitive thing that is going on here is, let me use the same color red, but now I'm going to sort of dot, right along the top of the surface here. And I want you to imagine that there is air right above the surface that is directly touching everything that was just being warmed up by the sun. Think of this as like a light bulb that is super duper duper hot, and as you're getting ready to touch it, you can tell that the air around it has also been warmed because it is touching the light bulb. And that second process right there of touching an object that's warmed by the sun is known as conduction. Because remember, the key to conduction is direct contact. So conduction is contact. So we have contact with it. And then the next thing that's going to happen that is even less intuitive has to do with what happens to the air once it starts to warm up. So let's go ahead and draw in some little boxes up here, and we're going to talk about the air. So one box here, and maybe one box over here. And I'm going to pull back out my red marker, and I'm going to color in some air molecules. 1, 2, 3, 4, 5, 6 over here. Maybe I'll get my blue marker over here, and I'll do 1, 2, 3, 4, the same 6 molecules. So let's talk about how air is different when it's hot and when it's cold. Now, when air is hot, it gets really excited and full of energy. And so these guys who are just hanging out, they're going to start saying, woo, here we go. And they're going to start zooming all over the place and spreading out. So over time, if I'm going to erase where they used to be there, there, and there, and there, and there, but they've been zooming around. Whoa, I erased a bunch of stuff. So let's go ahead and draw where they are now. Now they're over here maybe, and over here. And I had 6 molecules, but now those 6 molecules are all spread out on my red box because they went everywhere. And so we're going to say that hot air has lots of energy, so it spreads out. And because it spreads out, and this is the key, it is less dense than cold air. So over here, by contrast, we have our cold air. Our cold air did not get lots of energy, so it's been sitting there, and it keeps sitting there, bored, sitting there. And so instead of spreading out, it is low energy. It's just sort of clumped up. And so it is heavy, and it is dense. H-E-A-V-Y, heavy and dense, and sits there. So now, why don't we bring this picture? We're gonna sort of just drag it over here. Oh, let's not use blue. Let's drag it with black. We're gonna drag this picture over here. We're gonna recreate our ocean. Ocean. Whoa, there's a wave in this ocean. Happy shore. Happy tree. Happy tree. Okay. So we're gonna get air now that has been warmed up by the sun, and then warmed up further. Well, the surface was warmed up by the sun, and then by conduction, the air was warmed up, and so now it's going to start going up because I'm less dense, and less dense air rises. But once I rise, all of a sudden, I'm away from all this warm air down here. So then I want to start sinking. And what we find, especially above land and ocean, as this land, it gets hotter faster than the ocean. And so we find that we get this current developing of hot air going up, scooting over the ocean, losing its heat, its energy, dropping. But then even near the ocean, the surface is still warm because of radiation conduction. And we see there's this flow going on here, which we dub a convection current. Convection current. And now all of a sudden, we have the threefold process that is now bringing wind and air masses and moist air and cold, dry air all across the planet through radiation, conduction, and convection. And it's making one of these convection currents, driving all these major weather patterns. So, did you get it? Let's find out. If these next two sentences make sense to you, then I think it's safe to say you got it. Why don't we grab our typing utensil and let's scoot over here. I'm going to pick a nice big font, maybe 20, and let's talk big ideas from today. Big idea number one, radiation, convection, and conduction are the processes, let's make this nice and long, are the processes that move energy through the atmosphere. Big idea number two, hot air rises because it has more energy, so molecules are spread out and are less dense. Cold air sinks because it has less energy, so molecules are clumped up, heavy, and more dense. If you get those two big ideas from what we drew here, then that's a good foundation to build on to understand how weather develops and to understand what goes on in the upper layers of our atmosphere that don't involve weather and surfaces because of what occurs down below. Thanks for watching.